let me record. So, here's the volume, that is 190.072. So, nothing is hard here, class. All you have to do is multiply and divide, okay? So, considering a wastewater depth equal to 2 meters, if we have a volume, equal to 190.072. 190.072. If you have initially assumed that the water depth or your wastewater depth is now equal to 2.5, then the same requirements as a while ago, you need to determine the length and the width. So this time, we use length equal to twice the width. A while ago, we have used length is equal to 1.5 of the width. So this time, let's use twice. So we can do that. So the volume of a rectangular block or your tank is just equal to the length, the width, and the height. Wherein the height, oops, sorry, should be 2.0, not 2.5. Ayan, so 2.0. And then, multiply, you get a value in terms of your width. So, just a simple modification of that formula will give you a W equal to, or the width equal to 6.89 meters. Or round that off to the nearest whole number, that is 7 meters. Okay, so if I have now W, then I can now go back to my original equation, that is length, that is twice the width, and I get length equal to 14 meters. Okay, so that will now complete the dimensions of my tank, okay, or my aeration tank. So you also have, okay, the depth, the total depth, always compute the total depth, that is just the assumed wastewater depth plus your freeboard. Your freeboard is equal to 0.45, so just add them together and you get the depth equal to 2.45. Okay, so this is now the final dimensions of your aeration tank. The depth is 2.45, the width is 7, and the length is 14 meters. So if you draw this again in your AutoCAD, for example, then you have your influent here. Your wastewater will now enter here. And then we can design the pipe diameter later on. Let's just focus on the aeration tank first. So the length is now equal to 14 meters and the width is equal to 7 meters here. So again, you need to put a cross bridge here so that when you get a sample, because you need, kailangan every month, you monitor the efficiency of your unit processes. Kasi minsan, oops, I think it's not efficient anymore. I need to drain. I need to clean, something like that. So you need to put a cross bridge so that you can get a sample of that wastewater. Okay? Oops. Okay, so if I've cut a longitudinal section across that aeration tank, you will see this one. This one is a side view. So the depth is now equal to 1.55. Okay, kasi meron yung pipe dyan. And then your freeboard, that is 0.45. So this is now the railings of your cross bridge. So ito lang. It just showed you the section. This is 14 meters in length. Okay. So that's it. That's the design of your aeration tank. It's just like get the volume, assume a depth, and then the dimensions. So again, okay, so if you do not want a depth equal to 2 meters, 2 meters, so I would like to consider what if I'll make my tank deeper. Let's say that is 2.5 meters. And then assume that the length is equal to 1.5 the width. And then you can do the same process again. You know that the volume is equal to length times width times height. So you get W, okay, or the width, and you get W equal to 6 meters and the length equal to 8.66. So I think this is better, especially when you have an area that is not really that large. Okay, pagka ang isang constriction in the construction of your STP is the area, then you need to have a deeper wastewater depth. So let's say, let's adopt this one. The new width now is 6 meters and the new length is 9 meters. Oops, erase and okay, so naulit. Saglit lang class. Okay, so there. So for the second clarifier, if you do not want a depth equal to 2 meters, then you can have it as 2.5. And then the freeboard is now equal to 0.45. It's the same. This is a longitudinal section of your secondary clarifier. So this is now your inlet. That is now your pipe. Okay. And then sabi natin 2.5 kanina, right? But you can adjust that one. You can make it 2.2 and then your freeboard equal to 0.8. Because you need to position your pipe such that there is still water that will now pass through your pipe. Okay? Because if you will now position your pipe too high, baka wala nang lumabas na tubig. If you position it too low, okay, then some of the sediments might go to your pipe, blocking it. So you need to position your pipe in such a way that just enough water or effluent will now pass through it. Okay, so I think this is now the last one. This is for your chlorination tank. So after you have your Greek chamber, you designed your primary clarifier, and then your aeration tank, and then your secondary clarifier, and then you're now at the final stage, second to the final stage, that is your chlorination tank. So again, provide a freeboard that is, for example, 0.45, and let's say that the detention time is 15 minutes. Your Q, so after it has now passed, let's say, your Greek chamber, and then your primary clarifier, and then your aeration tank, and then your secondary clarifier, and then it now goes to your chlorination tank. So whatever volume goes through here should still be the same value. Okay, so we get volume equal to, if we have a detention time of 15 minutes, okay, the volume should give you 15.59 cubic meters. So the detention time multiplied by the discharge. The discharge is already given for you. The detention time is 15 minutes. Convert that to day kasi ang discharge mo is in cubic meters per day. So convert 15 minutes to day and then just multiply. You will now get the volume. Okay, again, because we want to determine the dimensions of that chlorination tank. We are not interested in the discharge. We are interested in the volume. So Okay, here, considering that my depth, the wastewater depth is now equal to 2.5 meters, and then considering a rectangular tank, pwede namang circle class if you want. I just want a rectangular tank. So let's say it's a rectangular tank, and I assume that the length is twice the width. Okay, so how to get the volume? Oops. How do we get the value, the volume? It's the same. Or how do we get the dimensions? It's the same. So this is now the volume of your tank. You are given that one. So you assumed a depth that is now equal to 2.5 meters, not accounting for your freeboard. And then you have your length and then your width. So I can just put it as length is equal to twice the width, so that I only have one unknown, which is the width. So after determining the width here, a simple calculation, algebraic calculation, we get the width equal to 2 meters. And then go back here, oops, there. So it should be twice the width. So length should be equal to twice the width. So 1.77 times 2 will give you 3.54. And that will now give you 3.54 meters, or say that is equal to 3.6 meters. So again, nothing hard there, class. Multiply, multiply lang. Get the volume, get the dimensions, and then that's it. So we can always check here that the volume that you have now, or the volume for the dimensions that you have adopted, should be greater than the incoming volume. And that give you 18 cubic meters, which is greater than 15.59 cubic meters. Okay, so adopt H equal to 2.95, L equal to 3.6, and W equal to 2.0 meters. Ay, ulit-ulit lang. Ayan. So, we go now to the design of your pipes. So, your discharge is equal to 1496.82 cubic meters per day. So, remember your formula, Q is equal to AV, or Q is equal to volume divided by the time. But you also have another formula, that is your Manning's coefficient. So, let's say that the roughness coefficient, your Manning's roughness coefficient is equal to 0.013. The slope is 0.008. So you can make use of your Manning's formula, that is just 1 over n r 2/3 s 1/2. For a circular pipe, the radius, or the hydraulic radius, is just the diameter divided by 4 raised to 2/3. So I know N, it's already given for you. You know R, or you do not know R because we are solving for the diameter. And then you know S, you know the velocity here. Okay, so you can now compute for your diameter. A simple modification of that formula there will give you a diameter equal to 0.16, or adopt a 200 mm pipe. Okay? So, hindi ko na in-explain, class, kung paano nakuha yung D, because you can do that. That is a simple calculation lang. And then, let me draw. Okay, so here, so if you want to go, velocity can be computed from the formula that Q is equal to AV, or from your Manning's equation, 1 over n r 2/3 s 1/2. So you are now given an equation in terms of the D, or that is now the diameter. And then modify your equation such that you can now solve for the diameter, and then you will get 0.16 meters. Convert that one to mm. Okay? Or sorry, you do not convert, you get the nearest pipe size that is commercially available that is equal to 200 mm. So ang next, ang mga pipe sizes is 1 inch, that is 1, 1.5, 2, you have 3, and then your 4. So 4 inches, okay, you have D equal to 200 mm. Do not choose a diameter size that is not commercially available. Okay? Kasi you will now go to prefabrication, which might be a little more expensive. So, you can now draw your chlorination tank. Konti na lang class. Last na to. Okay, so your chlorination tank, remember a while ago we have solved, if you are looking at the top view, this is now the top view. And then when I cut, okay, in a transverse section, okay, you get this view. It's this one. So at the top, you have diameter of your pipe, of your inlet pipe equal to 200 mm. And then the length is equal to 3.6 and the width is equal to 2 meters. Don't forget your freeboard, pwede nyong sobrahan, that is 0.5. Okay? Or pwede nyong ibawas dun sa depth kanina, that is 2.5. So anyways, that is how you compute for your chlorination tank and the pipe sizes. Okay? For the specifics of your sewage treatment plant, consult a sanitary engineer or take up a sanitary engineering course, pass your board exam, and then you can design the whole sewage treatment plant by yourself. So, okay, that's the end of my presentation. So, I'll give you a copy of this one. I'll group you. So, I have 2 announcements today. So, I do not have any more lectures left. Wala pa kayong activity sa akin. Wala pa kayong quiz. I think I haven't given you any research paper. I won't do that anymore. So, I'll just give you a group activity. You have to design the dimensions of a sewage treatment plant like what we did right now. And then, that would be by group. Don't worry. I will not give you a requirement that you cannot do for just a short period of time. Okay? So you will do this by group. By the end, I think before I'll give you your midterm exam, finals exam, your finals exam is on 17. So you have roughly 2 weeks to do your plate, your final requirement. So, I'll give the requirements on the soonest will be today, the latest will be on Monday. And then your grades, I'll give it Monday. Sorry, class, I haven't checked it yet. So I'll give it Monday. Your grades, your exam, I'll give it Monday. And then the plate, I'll give it Monday. The groupings, I'll give on Monday. Okay? And then the second announcement is that I'll try to contact someone from the DPWH or from the someone working in the government which is now concerned with the drainage layout or piping layout, but I am not promising class. So I'll set the time that he or she would be available. The thing is, you also need to be available at the time which might not be the same time as our class. So, I need you to be available when, kung papayag siya or if I'll get an outside resource speaker. Because I want you to understand how a drainage or a piping system is really laid out when you are in the outside world. You're not just confined here in the classroom. Okay? So that's my second announcement. But I'll contact them first because wala pang nag-confirm. Okay? So I think that's it. If you do not have any questions, wala. Okay, so if you do not have any questions, I'll end the lecture today and I'll see you next meeting. Okay? Goodbye.